Hi, this is Dr. Stephen Jones, and I'm your instructor for your Quantitative Analysis course. Let's start up with Chapter 1 and just some basics about information that you'll find in that chapter. This is a good introduction to the idea of what we mean by making decisions with data, and that data can take a numerical form or a non-numerical form. We'll get into more of this as we go along. So, to start off, what is quantitative analysis itself? Quantitative analysis is the concept that you use some sort of data information in order to make a better decision, in this situation a business decision, although obviously you could make other decisions that way too, but you don't make it based just on the data. You actually have to do something with the data in order to make it usable. So you have raw data out there, and then that raw data helps to lead you to some sort of quantitative analysis about the data. And then once you've analyzed the data, then it can give you the information that you need in order to be able to make a better decision. Why is the data itself not enough? Well, imagine this. Imagine if you looked outside and you saw that it was raining. Now, there's rain outside, and you just see that. All on its own, it's just rain. That is not enough for you to make a decision because you haven't formed any ideas about what you want to make a decision about. You just happen to look out and observe that there is rain. What does that mean? It just means there's rain. Now, that could mean any number of things. It could mean that there's actually a storm, rainstorm going by. It could be that you're misinterpreting as rain that there's sprinklers on the roof and somebody's throwing water off the roof and it looks like rain, but it's really not rain. It could be the start of a whole series of monsoons. Or it could just be a spring or summer shower. Just seeing the rain in and of itself is nothing more than data. You have to analyze that data. And so let's assume that you now look at that rain and you start measuring that amount of rain that's coming down. And it is rain, it's not a sprinkler on the roof. You recognize that there are dark clouds out there. You know, there might or might not be any lightning going on. But you can tell that it's rain, and you want to know the amount of rain. And so you start taking samples and other observations. And you see you've got a rain gauge out there, and it shows a certain amount of rain. And then you look out in your yard, and your yard's 6 inches deep in rain, in water that's out there. And so you realize, wow, that's a lot of rain, because this morning there wasn't 6 inches worth of water in my front yard. So that gives you something. You now have started doing some analysis. You've observed that there's 6 inches, and the analysis from that is I compare current state with 6 hours before, and notice there's a lot more water out there than what there was before. Well, that still doesn't make a decision, because perhaps you live in the bayous and you needed that amount of water out there, or perhaps you're in a small rural town and this now means that the whole place is flooded, and maybe your corn crop is gone, or you see your kids out in rafts and you go, wait a minute, kids, don't be riding those rafts out. Do you see what I'm saying? Just seeing that there's rain in and of itself is only data. It is not information yet. And even when you have quantitative analysis, all you've done is started to understand more about the data, but it might or might not be meaningful information yet. What you're needing to do is to find a way to make some coherent sense out of it, and that gets you then to actually having meaningful information so that you then can use that to make decisions. You can have quantitative data and qualitative data, or factors as they're brought up here. I'm not going to go into each one of these, but notice that while the weather does happen to be down there in the qualitative area, you can do, with specific types of weather, you can do some quantitative analysis, like have a gauge about how much rain you have, or how fast the wind is blowing, etc. So quantitative will have more mathematically oriented information or data out there, and qualitative will have mostly non-mathematically oriented information. With this, then, we have the concept of business analytics, where we're going to use the data, the analysis, and the information that we derive from all of that in making decisions, business decisions, doing the best that we can to make the best decisions out there. Descriptive analytics is looking at the data and saying, here's what it looks like out there. Not just looking at observations, but actually analyzing it and saying, here's what the lay of the land is like. Predictive analytics is doing the same thing, except now you extrapolate, now you predict, now you make assumptions about what the future could look like. Not necessarily, we're not saying woo or anything like that. You know, there's no hoodoo voodoo out of it. What you're saying is, based on what I've seen, here's what I would expect to have out in the future. Prescriptive analytics is not the same thing as descriptive or predictive. Prescriptive analytics is, this is what we ought to do based on what we know, because this is what, you know, these are the decisions that you should make in the future. So I'm a big baseball fan, so take it like this. Assume that you have a batter who in the past has safely been able to hit 3 out of 10 at bats and get onto base. So in baseball terms, that's a 300 hitter. 3 out of 10 times they are safely able to make it to base in their at bat. And so, and I know there's hit batsmen and walks, whatever. Let's throw all that outside. Let's assume none of that's in there. You hit the ball and you make it to first base safely. That would be descriptive analytics. Okay, we've described that person and their behavior based on what we've seen up to this point. Predictive analytics would say that next season we believe that they're going to hit at, say, 310, that is 31 out of 100 times they'll get on base. Because we've seen them improve by X amount each year, and next year then we would predict that this is what's going to happen. Prescriptive analytics would then allow us to try to maybe improve on that with the batter, and or make some other changes to our players that we also have on the team to make better use of this player out there. So we would now prescribe certain actions as a result of the analytics that we had been doing. Another thing to take a look at as we're looking at decision analysis is to look at such things as models. So one way to model data is to look at something like, as a formula as you see here. Profit equals revenue or sales minus expenses. So how much money we have left over at the end of the day is a function of, or depends upon, how much we sold and how much it cost us to make whatever it was that we sold. If we sold $100 worth of goods and services and it cost us $60 to make things and have sales personnel and to clean up the building and pay the rent and blah, 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 all of that, then revenue, or what's left over, is $40. So that is one way to take a look at kind of modeling data out there, having a formula. But there are different ways to look at revenues and expenses, and we'll get into more of that as time goes on. A different way to look at this very same concept is, instead of just doing the descriptive, like the profit equals revenue minus expenses, another way to look at it is to take a look at how much money should we make, how much stuff should we sell. And that's what you get in these next 3 slides. And we'll go into more detail, but I just want to show you the basic concept. So if you have the fixed cost for your building, your equipment, if you make nothing at all, it's still going to cost you $1,000 just to have had this business. It's going to cost you $1,000 just to have the building and the equipment. And all of that, you've got commitments out there. And that if you make things, in this situation in spring, if you make things, it costs you $3 to make those things. You pay the fixed cost of $1,000 no matter how many springs you make. And then for each spring that you actually do make, it costs you another $3. But you can sell those springs for $8. So if that's what you're looking at, you can say, one, how much money would I make if I sold, let's say, 1,000 of them, okay? So if I make 1,000 springs, then the amount of profit that I have left over is, notice the S, or sales price, is 8. The V, or variable cost, is 3, and my fixed cost is 1,000. So 8 times 1,000 springs is $8,000 comes in, minus the $1,000 I got to pay no matter how many springs I have. That leaves me with $7,000. And then I have to take off the cost of the springs themselves. That's another 3 times 1,000 springs, or $3,000. So 7,000 minus 3,000 is 4,000. That's how you get that to the bottom. So if sales is 1,000, then you have $8,000 in sales revenue, 1,000 in fixed cost that you take out, and 3,000 in variable costs that you take out. If you want to know how many you have to have just to break even, and break even point is an important thing. It means if I walk out of here and I don't owe anybody anything, but I don't have any money in my pocket, that's breaking even. And so if you're going to break even, you're looking at this and you say, how do I come up with it? Well, notice I've got another formula, and we'll go into more depth in this at a later point. But you can actually calculate that out by taking a look at this and saying, well, I have to at least meet my fixed costs. Remember, no matter if I make no springs at all, I got to pay $1,000. So what I'm looking for is what's called a contribution margin. That is how much something can be sold for minus how much it actually costs for that unit, whether it's a unit of time or spring or whatever it is. And in this case, we got to pay $1,000 no matter if we make nothing. But for each unit that we actually sell, we make $8 and it costs us $3. So in the end, the profit for any one unit is $5. So if we need to cover $1,000 worth of fixed costs, $1,000 divided by the $5 that we made by that one unit means we need 200 units. 200 units times $5 worth of profits per unit gets us $1,000. That's enough to pay off the fixed cost. We don't walk away with any profits, but we also don't walk away with any debts. Okay, that's what we mean by break even. Now, over the course of this time then, we're going to see that in each chapter we find other ways, other tools that we can use. And we'll go through them step by step, folks. You take care.